Rain1290 once again with you to bring you another risk analysis for another thunderstorm opportunity for June 10th, 2025. So there is some risk during the afternoon period specifically for these regions, and even during the pre-dawn period as well, but to a lesser degree. But the focus, I think, will be during the afternoon period. So let's get right into it. Okay, so a good place to start is by looking at average cloud cover. So just to give us a hint of how much destabilization would occur just based on solar heating. So going forward in time, so now we are going into June 10th. So June 10th, this is about pre-dawn, 2 o'clock in the morning. And going forward in time, so later morning now, about 8 a.m. and now 11 a.m., you start seeing these breaks in the cloud deck starting to emerge in Eastern Ontario, as represented by these darker shades, right? So anything in white is cloud cover, anything in dark are breaks in the cloud deck. You start seeing these sizable gaps in the cloud deck starting to emerge later in the morning and heading into the afternoon. So that will help to improve the amount of solar heating that will start taking place at that time. Okay, so to be a bit consistent with those breaks in the cloud deck, we want to look at low-level lapse rates, which refers to how quickly temperatures are decreasing with increasing altitude in the lowest altitudes, essentially. So going forward in time, once again, just like average cloud cover, if you look at, this is now tomorrow afternoon around 2 p.m., notice how these brighter colors start to emerge in Eastern Ontario, Southern Quebec, and upstate New York. You know, these reds, ambers, and yellows, so representing very steep low-level lapse rates. So this is consistent with those breaks, and you can see particularly strong low-level lapse rates taking place in Eastern Ontario, southern and southwest Quebec, including around the island of Montreal. Okay, now looking at mid-level lapse rates for tomorrow. So right now we are at the late morning period in this animation. So if we go a bit further in time, roughly when we would expect thunderstorm development to take place, we're actually seeing some steeper mid-level lapse rates or cooling rates taking place, as represented by these darker shades of gray and some patches of green. But we're actually seeing these steeper rates taking place and overspreading the region tomorrow afternoon into the early evening. But the risk is most important during the afternoon for thunderstorms. So these cooling rates are actually unfolding during that time and taking place with the steeper low-level lapse rates that I showed previously. Okay, so now turning our attention to dew point temperature. So as you might remember from my last forecast video, the dew point temperature represents the amount of moisture in the air. So it's a way of quantifying how much humidity is in the air, essentially. So as we move into tomorrow, June 10th, so again, we're at about 2 o'clock in the morning, as represented by this time frame. So going forward, we're sort of engulfed in these greenish colors, but going forward, notice how these blue colors start to emerge into the afternoon, representing higher humidity. So dew points of approximately 60 to 65 Fahrenheit. So, which is about 14, 15 Celsius-ish, around that point. So we are getting a boost in humidity during the mid-afternoon. So it's around 2 p.m. when these blue colors start to emerge to help improve instability as they join up with those steeper mid-level lapse rates and especially the lower level lapse rates. Okay, so putting this all together as a way of quantifying the amount of instability that's in the air, we're looking at CAPE, C-A-P-E, convective available potential energy. So what this does, it sort of pretty much combines all of the factors that we looked at from low-level lapse rates, mid-level lapse rates, the amount of humidity that's in the air is represented by dew point, and puts it into one nice, tidy little figure. So what we see here is the amount of CAPE that's emerging into tomorrow. So this is later in the morning. Well, now it's about later in the morning. So you can see that higher amount of instability is starting to emerge in tandem with the increased clear breaks in that cloud deck, plus the increasing amounts of moisture and the steepening lapse rates. So this is in the mid-afternoons, roughly when I expect thunderstorms to emerge, so taking advantage of this maximized instability of approximately 1200 joules per kilogram. So CAPE is measured in joules per kilogram, that's what these units are. So we see a bit of a maximum around the island of Montreal and going south. So favorably, I would expect thunderstorms to take advantage of this along that frontal boundary that I'll mention in a bit. Okay, so looking at our synoptic chart, so at the surface, this shows us different areas of pressure. So high pressure represented by blue H's, low pressure represented by these red L's, as you can see here. So in extreme eastern Ontario to southern, southwest Quebec, and much of the northeast, we have this cold front that's becoming occluded. So I won't go into what an occluded front is in this video, but it's represented by this purple line, the occlusion. But in general, we still generally have a cold front that's affecting this entire region for tomorrow. So this is for tomorrow morning, and we can see the positioning of that cold front. But as we go further into the afternoon, late morning afternoon, this cold front will start to become more important, and it looks like it will be able to take advantage of that maximized instability that I mentioned. Okay, so looking at surface moisture convergence as a means to validate the amount of lift that's taking place along our front. So we know it's a cold front. We know that's going to be taking advantage of the instability, as I mentioned before, but we want to evaluate how strong that cold front is. So as we go further into tomorrow, so what we're looking for are these brighter colors, just similarly like in the other maps, like the ambers, the yellows, the reds, and even blues in some cases. But as we go further in time, so this is later tomorrow morning now, notice how these brighter colors are starting to emerge, like these yellows and ambers. So as we go further, notice carefully now how it strengthens. So this cold front is fairly strong, and it looks like it will help to increase the amount of lift, or the amount of surface convergence, surface moisture convergence. So based on this, I do expect the cold front to be more influential and be able to actually utilize that amount of instability that will make itself known tomorrow afternoon, as shown in the previous maps. Okay, so looking at a skew T log P diagram in order to synthesize everything we just discussed, so we actually see this area of instability, the amount of CAPE, represented in this gap over here between this dashed blue line, which is the parcel temperature, and this red line, which is the environmental temperature. So you can feel free to check my other videos to actually just get an idea about how to read these plots. But in general, this dashed line is the parcel temperature, the dashed blue line, and the red line represents the change in environmental temperature from the surface, which is down here at approximately 1000 millibars, that's where we are, and going all the way up to and past the tropopause. And the green line represents the amount of moisture in the air and how that's changing with increasing altitude. So just based on this, and also looking at these wind shear profiles, so these wind barbs on the far right, so we see the positioning of these wind fields, and they're actually pointing in approximately the same direction from the surface all the way up the tropopause. So, and the speeds are actually increasing as we go above. So some sizable speed shear is taking place based on this profile. So what I would expect is a decent amount of organization in terms of thunderstorm development. So I expect these thunderstorms to be forming in groups and eventually create scattered coverage. Now, the other thing I want to mention is the 500 millibar temperature. So again, just like in the last risk assessment, we have a 500 millibar temperature. So again, kind of giving you an idea how to read these. So we're at the 500 millibar altitude, 500 millibar constant pressure level, and going from this red line diagonally down, so following these diagonal lines downward to the base level, which is the surface, we get a temperature of about minus 14 to minus 15. So to me, that suggests some risk for small hail with some of these thunderstorms. And based on the strength of these 500 millibar and surrounding altitude wind barbs, the wind speeds will be enough to propel these thunderstorms pretty quickly. So they'll be on the faster side in terms of movement. And they'll be able to organize a little bit more easily in scattered fashion. Okay, so giving a summary of what we just discussed and talked about, so I expect thunderstorm coverage to be scattered. There should also be a small hail risk. And the dominant spread, I think, will be, again, locally heavy rainfall. But unlike the last risk analysis that I posted previously, I think the lightning frequency has a better chance of becoming more moderate in tendency. These thunderstorms will also be faster moving because, again, of those wind shear profiles that I mentioned, especially those stronger 500 millibar and surrounding altitude wind speeds, which will help propel these thunderstorms a bit quicker from west to east. Okay, so based on these observations, I would expect thunderstorm initiation to favorably happen pretty close to the island of Montreal along this zone, and then start to move quickly off towards the east to northeast. So something like that. They'll start growing in number, I think. So remember, as I mentioned, scattered coverage. So I think they'll start in isolated fashion along this red line that I drew in here. And I even draw it a little bit farther south as well. And they'll start growing in number as they start moving off to the east. So with eastern progression. And some of these thunderstorms can have a decent strength as they move off to the east and become more organized as they start approaching or encroaching on the eastern townships. So this will be something to watch. So the initiation zone could be actually more in southern southwest Quebec than in eastern Ontario, although I wouldn't rule out a few isolated thunderstorms forming in eastern Ontario before they make their way into Quebec and even into upstate New York. Okay, so there you have it. That'll be the risk analysis for June 10th, 2025. If you found this video helpful to you in any way, if it helped to cast some more light onto the situation, feel free to subscribe to this channel so you do not miss out on upcoming forecasts for upcoming thunderstorms altogether. Apart from that, I'll see you in the next video. So thank you very much for your attention. Cheers.